Hi friends, here we are given a geometric progression and we are given that Sn is the sum of first n terms of that particular geometric progression or any geometric progression. Sn is sum of n terms of geometric progression. We have to prove Sn by S2n minus Sn equals S2n minus Snb S3n minus S2n. Right. So because it is geometric progression, we have to find some way of getting the ratios. Here also we are given ratios. Let's see what is this Sn. Let's try to find out what is Sn, what is S2n, what is S3n, and try to create these ratios and see how to equate both of them. Right. Any geometric progression we know will be in the form AR square up to AR power n minus 1 nth time. Right. What is nth time? Nth time is AR power n minus 1. Right. We want Sn, S2n and S3n to calculate this. Right. What is Sn? A plus AR square till AR power n minus 1. What is S2n? S2n is whatever again. A plus AR square plus AR until AR power n minus 1. This is anyway Sn plus until AR power 2n minus 1. 2n. So AR power 2n minus 1. Right. Just one lesser than 2n. Right. S2n is A plus AR square until AR power 2n minus 1. Right. If you observe, 2n will have got all these terms common plus this extra. What is extra? Extra from n plus 1th term. Right? First n terms are anyway common. What is n plus 1th term? A r power n plus 2 term, n plus third term, whatever. This is the 2n term. So S2n minus Sn will be, these all will cancel out. Will be left with n plus 1th term to nth term, which is nothing but AR power n plus AR power n plus 1 plus AR power 2n minus 1, which is nothing but if we take R power n common from all of this, we'll be left with A plus again AR plus AR square plus AR power n minus 1. Right. Please notice this AR power 2n minus 1. If we take R power n common, we'll be left with R power n minus 1. Right. Don't get confused here. R power 2n minus 1 equals R power n plus n minus 1. Right. So if you take R power n common, you'll be left with R power n minus 1. Right. What is this one? A plus AR square, whatever all of this. This is actually exactly Sn. Right. First n terms only. This is exactly first n terms. So S2n minus Sn is actually equaling R power n into Sn. Right. So far, so good. Right. So what does that mean? Sn by S2n minus 1. Sn by S2n minus, sorry, S2n minus Sn. It will become 1 by R power n. Right. This is equal to R power n into Sn. So Sn by S2n minus Sn equals 1 by R power n. So far, so good. So this left part we have equated that to 1 by R power 2n. Now let's talk about the right part. Right part, this the the first term we already know, right? First term is already this r power n by r power n into Sn. What about the second term? S3n minus S2n. Right? What is S3n? S3n is everything up to first two n terms plus 2n plus 1 term to 3n. Right? First two n terms are common between S3n and S2n. Right? Then after that it will have 2n plus 1, 3n minus 1 terms. Right? S3n minus S2n will become then AR power 2n plus AR power 2n plus 1 plus until AR power 3n minus 1. Right. In this also we can take 2n common. Right. If you take 2n common, we'll be left with again a plus AR square plus AR power n minus 1. So 3n minus 1 we can write it as n plus 2n minus 1. Right. 2n plus n minus 1. If we take the 2n common out, we'll be left with n minus 1. Right. So this becomes r power 2n into Sn again. This inside part is again Sn. Right. Now we have got these two terms S2n minus Sn, which is r power n into times Sn, and S3n minus S2n, which is again r power 2n times Sn. If you divide both of this, left with r power n times Sn by r power 2n times Sn, right? Which is nothing but Sn will anyway get cancelled. R power n by r power 2n will become 1 by r power n, right? Please notice this r power n by r power 2n means r power n into r power n. So one r power n will go. So we'll be left with 1 by r power n. So the first term, this time we have proved that it is 1 by r power n. This also we have equated this as 1 by r power n. So both of these are equal, which is again equal to 1 by r power n. Right. This is a nice problem. Just that we need to expand these terms and understand the relation between this and this or this and this. What are the additional terms? Right. And then this becomes straightforward. Thank you guys.